Catus Maximus here. This time, a quick review and teardown of this old Montgomery Ward Powr-Kraft tool. Some people complain that I don't do enough old tools. Some people complain that I don't do enough. Or excuse me, that I do too many. I just kind of do the tools that catch my curiosity. The reason I am doing this video is mainly because almost all the rotary tools over the many decades, at least in the United States, were all made by Dremel. There were ones that didn't actually say Dremel, were just rebranded. So there's not too many, at least of ones from, say, the 50s through the even 80s and 90s that weren't actually Dremel brand. Nowadays, there's just a ton of knockoffs of rotary tools. But a few decades ago, there weren't too many. Montgomery Ward actually had decent hand tools, but a lot of their power tools were only okay. They weren't super great. This is a case in point. This is a non-ball bearing unit. It is 30,000 RPM. It is not variable speed, but it does have a 0.8 amp motor, which is okay. But around when this was made, Dremel had already moved up to their like 1 amp or 1.1 amp motors. And of course, Dremel's been ball bearing for a long time. Ball sleeve bearings like that are used in this tool are generally okay in many situations, particularly fans and stuff. But in a rotary tool like this, you're putting a lot of sideways force, and there's a lot of vibration, and there's a lot of grit. And sleeve bearings, that's not the conditions you want to use them in these. When the grit gets in there, you have a lot of vibrations and combined with a lot of lateral forces. They do wear out and can give you issues. They also have more friction in these situations, so the tool bogs down more. You can almost hear that when it starts up. You hear it starting slowly accelerating because there's still a little bit of oil. The oil-like bearings that are in these is actually a sintered metal, but it's crushed in with an oil, so as it slowly wears, oil seeps through the microscopic particles, lubricate it, and known as an oil-like bearing. And under high-speed situations such as this, there can be issues with oil burns, and so it creates a little bit of tackiness. As this runs for a few seconds, it starts to heat up that base oil and allow it to float a little more freely. So it just isn't those type of bearings in a tool like this just isn't a very good option. At least it's pretty quiet. Has quite a bit of airflow, but I think that's really to overcome some of the extra friction the motor has to deal with. Other issues is that the spindle can pull in and out a bit, and that allows for increased vibration. One of the big deals with the ball bearings and the Dremel is that the spindle's held really tight, not just laterally, but in and out, because of course you can get situations where it pulls in and out and then it actually can get an oscillation really wants to. That play allows room for more vibrations to develop. Has a really kind of cheesy sheet metal lock for the spindle for you to unscrew it, but it does use standard Dremel collets, and the threading is the same size, but it doesn't have any case threading, so you can't use any snake accessories or anything like that. So just kind of a weird little Montgomery Ward Dremel rotary tool, just a simple switch from the back. It does have a lot of airflow, but nothing too exciting about it. But besides the bearings that I already know about because I could see through the window, I'll take it apart and we'll take a look inside. It's just using a kind of weird little metal clip or snap ring right here. So I'm just going to try to, without stabbing myself, get this ring off of here. It's not going to be easy. This tip of this little screwdriver does not want to get under there. This little ring was a little bit more of a hassle to take off than I expected there. And just a few Phillips head screws on the back side here. And knock this whole thing apart. This isn't so old that this feels like a Bakelite case, but it may indeed be. I'm not so sure. It's certainly older than when they started actually deciding to label the plastics that power tools were using. That's actually a more 90s and later type of deal. One of my most used tools here is this little skill, surprisingly enough. Little screwdrivers like that make things pretty simple. And as with most power tools, but not all power tools, you usually pull off the back side of the case first. And everything usually stays in the top. There we are. We can actually see a little metal clip to try to prevent the field from the motor from vibrating too much. That's kind of a neat idea. And there is no stamping inside this to indicate what grade of plastic it is. And then that's all Dremels really are. They're just a very simple tool. It's an electric motor with a power switch. This little thing up here is a ring spring, which is what's holding the lock lever. The lock lever just slots into that little area. At least we can see that it doesn't appear. Oh, it's been hit a couple times. No, just once it appears. You really know as when you look inside. If somebody's hit the button while this is running, it just tears that up. Okay, I had to take a look at this. Thing is actually a little bit cheaper than I thought. One is that the actual collet sleeve, even though it's a Dremel threading, is much shorter than what a standard Dremel one is. But the collets are indeed more modern. If we get this motor out of here, I may have to pry on those little bearing clips. It's pretty cheesy. They're just using a piece of plastic as the thrust plate. Since the sleeve bearings have to be held, they just have these weird little metal clips over the sleeve bearings to keep them in place. They use these spherical outer diameter ones because they they do a form of self-aligning. Okay, now I finally got those clips off. We should, surprisingly enough, this thing is really pretty well jammed in here. It's kind of weird almost. There's actually some clever designs. These little bungs of plastic are actually little catches that are what hold the brush holders down. It's kind of interesting, but that's how cheesy this tool really was. Is they're just using that little bit of plastic to hold this in there. And then there's notches on the side of the case. I just lost a bunch of stuff. That are what end up holding the field into the side of the motor or into the side of the housing. Okay, and so here's some of my issues. So on this tool, they actually have these little cotton felt pads which hold additional oil to help give some more lubrication. And then this right here, this is literally, this appears to be a piece of nylon. That's the thrust plate. You can see it's already wearing. So when you're using this tool, all you're relying on is just the back of the motor shaft pressing on that. So that's one of the reasons it has very poor performance. Also, if we pull off this field here, now this thing doesn't really want to cooperate getting it. There we go. We can see that it isn't a particularly great motor because it isn't designed for higher power or higher specific power. And how you know that is because there just isn't very many commutator bars. On higher performance motors, they have really narrow bars so that the brush can contact and activate more coils in a given moment, giving it a lot more power. The other thing is we can see quite a few balancing marks there. More there, and even more there, so it's okay. But for such a small motor, it's still quite a bit of balancing. No real protection. It's just a little bit of lacquer that's been dipped in. Those are just crimped connections against hair-thin wire. You can see how thin this wire is. You just get a couple little particles of wood. You can knock some of those wires off. So not super great. Here are those oil light bearings. They're actually, the surfaces are okay. How they self-align is when you put the motor in there with those spring things, they kind of self-center. But they are cheaper. It's much cheaper to center this little piece of bronze than it is to make a ball bearing. Besides that, there's not a whole lot else going on. Just a tiny little field here, tiny little motor, and even the back housing was actually grounded. So kind of surprising how simple these little rotary tools are. Because really, they're just a small little electric motor. What's kind of interesting is that you can make brush electric motors pretty much to any size. They can be super tiny like this, all the way up to just massive motors. So anyway, I really appreciate everybody who's been watching and subscribing and took a look at a teardown of an old Montgomery Ward Dremel tool. Anyway, if you haven't subscribed, please do. Till next time, Catus Maximus out.